The title then of the workshop is Ecological Principles Underlying Ecosystem Function on Land and in the Ocean. It's perhaps a little unusual to have this as the theme of the workshop. Comparisons between terrestrial and marine ecosystems are generally not in the mainstream of scientific literature, as I'm sure many of you have noted. Yet there are several points for which the transfer of knowledge and concepts relating to one or to the other system would benefit our understanding of both. At least that's my opinion. I think I mean, at first sight, there are specific features that strongly differentiate, life on solid Earth from life in the liquid ocean. For example, concerning primary producers, right? Plants, higher plants, large macroorganisms on land versus microscopic phytoplankton in the ocean, which both perform, the function of generating organic matter that feeds the rest of the ecosystem, by and large. Yet the interactions between the scientific communities tend to be very disparate, very limited, because of these, fundamental differences in what we consider terrestrial versus ocean ecosystems. The scientific communities working on these topics don't often get together, so the interactions between them are quite unusual. So I'm very happy that you have all agreed to come together for this workshop to look through this topic together. And so the way we're going to run this afternoon session for the next few hours, we're going to look at sort of an overview of ecosystem structure function in different contexts. We're going to begin with a sort of deep past context. Looking at more or less deep lengths of time. I'm sure Andy and Hélène are going to present different aspects of temporal dimensions from their own studies. And then we'll move to ecosystem structure function in terrestrial ecosystems. Through a series of speakers. Then we'll have a small break, and then we'll jump into the ocean and aquatic ecosystems to look at ecosystem structure function in those, in that context. And then we will go into a bit of modeling work, in particular. Some of the work I think is particularly interesting from Mike Harfoot, developing a general ecosystem model covering both land and sea. I think that might be interesting for us to look at. And then we'll end up with a synthesis and discussion led by Maurizio Ribera to go through the different things that we've heard today, and hopefully have some interesting discussion. So basically the objectives of the workshop, you've seen this before, it's in the notes, is sort of to discuss the structuring of both terrestrial and marine ecosystems, including both the macro and the microscopic components, in terms of ecological and evolutionary principles, biodiversity, ecosystem functioning, BEF, community and meta-community concepts, and so on. With the aim being to contrast what we know of land ecosystems versus ocean ecosystems, and also how knowledge from one can inform the other. So what are the barriers and the limit to this flow of information between we as the scientific community? And are there some aspects that are likely to be fundamentally different between micro and macro organisms in terms of their ecosystem structure, and between land and sea? So if you can think about those sort of general objectives throughout the next few hours, that would be great. and we're hopefully going to have a nice interactive discussion together. So there are about 10 of you online, I think, and there's about 10 of us present here in the audience at the Collège de France. It's a pity you can't see this magnificent building in the heart of Paris. You can only see me, I guess. But we have several people present in the room as well who will also be interacting through the discussion. And we have a few young people who have agreed to be rapporteurs, who will take notes throughout the day. You know, hopefully, if it turns out to be a nice afternoon, with some general ideas emerging, perhaps we can, you know, generate a review or opinion paper after the event, aimed, for example, at cross-fertilizing concepts, providing some suggestions to fill knowledge gaps, and ideas for how to integrate the knowledge into Earth system models more generally. So I thought I'd put up this cartoon just also to provide a little more context, which I took from a recent review in Trends in Ecology Evolution by Thomas Webb, which really sort of deals with the topic that we're going to talk about today. As I say, there's not much in the literature that talks about comparisons between the two systems, but I find this review is quite interesting and enlightening. So marine and terrestrial ecology, unifying concepts, revealing differences. So in this figure, we have terrestrial and we have aquatic ecosystems, and what are shown here are some potentially informative comparisons that could be made between the two. So just taking some examples, for example, macroecology of complex assemblages, we could consider sort of comparing sort of bird populations with fish populations, diversity in stable habitats. You could perhaps think of comparing like coral reef type systems with tropical forest type systems. Community structure in similar environments, perhaps soil versus marine sediments offer some opportunities there. Some same taxon, different environments, for example, gastropod mollusks on land and in the ocean would be interesting to consider. Same functions, different taxa, for example, concerning carbon storage, on the one hand in whales and on the other in trees, is an interesting analogy. Anti-predator behavior, for example, wolves and elk against sharks and dugongs. And finally, trophic interactions, for example, size-structured pelagic versus taxonomic terrestrial comparisons. So that's a bit of context for you that will hopefully get you thinking about where we can perhaps make more some contacts between different fields. And I just want to end my introduction just by putting up this really the last paragraph in this review, which I think is interesting as well for us to consider through this afternoon. So I'll just read it out. However, exploring when ecological theory can cross the land-sea boundary, and equally importantly, when it cannot, can be revealing. Reflecting on differences, even if they are not real, or if real, intractable, at least gives one pause for thought about what might actually matter. If one embraces the variability within and among ecosystems, is it possible to tease out generalities in the way that putative ecological rules are contingent on specific biotic and abiotic settings? We must hope so, because predicting how communities will respond to environmental change will depend on it. So, yeah, that's the larger sort of call to arms since we are in troubling times, having to deal with climate change and how ecosystems are going to respond to changing climates, both on land and in the ocean. This is sort of a call to action to at least try and improve our knowledge of how the whole system works. So I think with that, I will end my little introduction and. They don't hear me.
Ils t'entendent, mais nous, on les entend pas.
Okay. Okay.
Je viens de prévenir la personne.
Okay. Okay. So I think now we can switch the microphone, and then hopefully you will be able to hear the first speaker, which is Andy Knoll. So if there are questions in the room, then I think you just need to come up and talk from here. Okay. So I can exit here. Well, I'll let you do it. So the first speaker is Professor Andy Knoll from Harvard University. Doesn't really need much of an introduction, obviously. His contributions to understanding the deep history of life on Earth have been remarkable throughout his career. And I think Andy's just going to provide some nice context on sort of how ecosystems perhaps have been built, how they've evolved, how they've functioned over different time scales, in particular deep time. So shall I hand over to you, Andy?